Assalamualaikum dan good afternoon. Welcome to my video number 19, ya. Implicit differentiation. Implicit differentiation. Okay, so we consider for the two-dimensional case, we consider the function. Consider the function. Let's say f xy equal to 0, where our f or y, sorry, is a function of x. So obviously in this case, if f is continuous, if continuous, and f is differentiable, f differentiable if f is differentiable. Okay, so therefore I can write this function, because y is a function of x, so I can write this function as f is as a x, y is of fx that equal to 0. Okay, if we differentiate this function or this function with respect to x, what we do actually, we differentiate with respect to each of its variable. So in this case we have two variables, even though y is a function of x. Okay, but in this case y is still a variable, so we need to differentiate y as well. Okay, so if we differentiate with respect to x, differentiate f with respect to x, okay, we differentiate f x dx plus del f del y dy dx, that equal to 0, because differentiate 0, we got 0. Okay, why do we get this? This is from chain rule. If you remember, that's in my video number 18 or 17 or 18, so that I talk on the chain rule. So we apply the chain rule. Okay, so dx, this is 1. Okay, dy dx, we consider that's not 0. So therefore from here we can find, we want to find dy dx, so we can find dy dx is equal to, just rewrite those expressions. So we have, this is minus fx over fy. So where fx is actually del f del x, and fy is actually del f del y. Okay, so I give you example for this example. Find y prime if x cubed minus y cubed is equal to 6xy. Okay, so we can write this equation in terms of function like that. Okay, and equal to 0. So in this case, solution, I can write f x y as those x cubed minus y cubed minus 6xy. You bring it to the left, then equal to 0. Right? So we want to find y prime. So you can just apply those directly, or you can basically differentiate those equation, or you can apply the formula that we obtained earlier. So if you apply the formula, we have y prime, which is dy dx equal to negative, because we have negative here, yeah, negative. Then fx means we differentiate that, this is f, differentiate that with respect to x, so we have 3x squared, that one is 0, this is minus 6y, right, over that part, negative this part. So fy is we differentiate that negative with respect to y. Sorry, this should be plus. No, this should be plus. So we have 3y squared minus 6x, right? So then you can just here you can just simplify this. You can factor out 3, so you have x squared minus 6, minus 3y 2y over y squared minus 2x. Okay, so that's the way we differentiate. Or you can just differentiate directly from there, just as I think you are used to it. So just if you differentiate, we want to find dy dx. This is 3x squared minus 3y squared dy dx minus that one is 6. Differentiate respect to x, so we have y minus 6x dy dx. You can also do this. This is equal to 0, and then you simplify all these things. You get that again similar answer there. Okay, so that for the case function depend on x and y variable. If you have 3 variable x, y, z, for example, yeah, so we let z as a function of x and y, and our f is a function of x, y, z, that equal to 0. Alright. So if f differentiable function, then f also differentiable function on its domain. So if you differentiate this function with respect to x, okay, differentiate f with respect to x, differentiate f with respect to x. So what we have? So we have using chain rule, yeah, using chain rule. All right. So del f del x plus differentiate respect to y del x z del f del z del x. Then right hand side is 0. Okay, this one we have del x, this is 1. Okay, y is a variable, differentiate respect to x should give 0. This is 1. Okay, that one is 0. Then from there, if you simplify this, you're going to have del f del x plus del f del z del z del x, that equal to 0. All right, so therefore we have a relation del z del x, this is equal to negative, you can see from there, fx over fz. And you can also do this one, we differentiate with respect to x. Okay, you can also differentiate with respect to y. If we differentiate f with respect to y, so what we're going to have? So we have del f del x, right, del x del y plus del f del y plus del f del z del y, that equal to 0. Okay, remember that chain rule. we differentiate respect to each of the variable of f. So we differentiate each of the variable of x of f. F we have x, y, and z. So we differentiate with respect to each of them. Okay, del x del y, of course this one is 0 because x is independent variable. The del y, this is 1. So what left is del f del y plus del f del z. That one is del z del y that equal to 0. Then you can find del z del y is negative of fy over fz. Okay, so let me give you a very simple example just to show you how can we apply this formula. As in the case of 2 variable, now this is for the case of 3 variable. Example, find del z del x and del z del y. Yeah, find del x del z del x and del z del y. If our function z cube plus y cube, this should be x, I guess this should be x plus z cube plus 6x y z equal to 1. Okay, first of all we need to identify our function. So our function f of x y z is given as, we just bring it to one side. So we have x cube plus y cube plus z cube plus 6xyz minus 1 that equal to 0. Then you can find what is del z del x, del z del x. Del z del x, you have negative of f, del z del x, negative of fx over fz. Okay, so this is equal to negative fx is 3x squared, that one is 0, that one is 0. Okay, so that one is what, x plus 6 yz divided by fy. So we have 3y squared plus 6 xz. That's all. Then you can simplify, factor out 3, that you can do that one. The same thing you can find del z del y, del z del y. Okay, del z del y is given as negative of fy fz. Alright, so this is negative of fy is 3y squared plus 6xz over fz is 3z squared plus 6xy. And then again you can simplify. Alright, so I think that's all for the for this section. Video number 19. We meet in video number 20. Okay, bye bye.